Hey everyone. So far this unit, we've done multiplying and dividing with rational expressions. So today we're going to start adding and subtracting. Specifically, we're going to look at adding and subtracting with like denominators. So you may recall from elementary school that when you add or subtract fractions, you have to have like denominators. So when you have like denominators, you would add the numerators, but the denominators stay the same. And then you would simplify the fraction from there. So when we are doing this with rational expressions, we're going to check for common denominators. If we don't have them, we're going to create common denominators. We're going to combine the numerators over the common denominators as one fraction, and then we're going to try to simplify using our techniques from 8.1. So let's try this out. So looking at number 1, I see common denominators and a minus sign. So that means I can subtract. I know the bottom is going to stay the same. And on the top, we actually can subtract because these are like terms because our exponents match. So 14 minus 6 gives me an 8, and then the exponent stays the same. Now that it's a single fraction, I can use my simplifying techniques. So 6 and 8 are both divisible by 2. So this turns into a 4, and this turns into a 3. My x's, there's an invisible 1, so 3 minus 1 equals 2. So we are left with a 4x squared, and on the bottom, we're just left with a 3. Number 2, I've got a subtraction sign, and I see common denominators. So my denominators stay the same. And on the top, these are not like terms, so I'm just going to write them next to each other. Then simplifying, I see 2 terms and I see a minus sign. So 2 terms and a minus sign tells me I can do difference of squares if they're perfect squares. And luckily they are. Square root of 25x squared is a 5x, square root of 9 is a 3. So on the top, we've got a 5x plus 3 and a 5x minus 3. You always got to have the plus and the minus. And on the bottom is the 5x plus 3. Oh, nice. We've got a 5x plus 3 on the top and a 5x plus 3 on the bottom. So they simplify to equal 1, which turns invisible. So all we are left with is that 5x minus 3 on the top. Because it's on the top, we don't have to put anything on the bottom because the bottom has simplified. Let's look at number 3. I see common denominators, so that's nice. So let's add these together. The 6 and the 2 are like terms, so the 4x stays the same, and I can add 6 plus 2 is 8. And then the common denominator stays the same. Then I check for any simplifying we can do. So on the top, I see a GCF of 4. So I'm going to take out the 4, and I'm left with x plus 2. On the bottom, I see a GCF of 4x. So I'm going to take out a 4x, and I'm left with x plus 2. Oh, perfect. So x plus 2 and x plus 2 cancel. 4 and 4 also cancel. Since nothing is on the top, make sure you do the invisible 1. And on the bottom, we are just left with that x. So we've simplified it all the way. So I find these units to be really satisfying because I really love canceling things out that equal 1. All right, number 4, I see a plus sign. I see common denominators. So common denominator will stay the same. And on top, I see some like terms that I can add together. So the x squared stays. 8x plus 2x is 10x. And then 21 stays the same. Then I want to try to simplify. So on the top, I see a trinomial. So I'm going to try doing the x. So 7 and 3 work. So the top turns into x plus 7, x plus 3. The bottom, I see difference of squares because I see 2 perfect squares and a minus sign. So we get x plus 3, x minus 3. So looking to simplify, I have 2 groups that match on the top and bottom. So I'm left with an x plus 7 and an x minus 3. This stays really short, only 2 more. So looking at number 5. Okay. So number 5 has a minus sign. So something you have to be careful with is when there's a minus sign and there's 2 terms next to it, you want to distribute that minus. So just like we did earlier, you want to change the sign. So I'm going to change the signs of everything on this side and turn this into a plus sign. The reason I do that is because frequently people will forget to subtract both of these. So we do want to do the changing signs when we have a minus with more than 1 term. So we do have our common denominators. And on top, the n squared stays the same. 3n minus 1n is 2n. Negative 7 minus 1 is negative 8. So top I see a trinomial, so I'm going to try to factor. 4 and negative 2 look like they would work, so we're left with an n plus 4, an n minus 2. The bottom, we've got a negative 6 and a 1, another trinomial. So we've got a 3 and minus 2 should work. So n plus 3, n minus 2. Then we check to see if anything simplifies, and the n minus 2's turn into that invisible 1, so they cancel. So we are left with n plus 4 over n plus 3. All right, I would recommend trying the last one before you see it. So this one has a plus sign, and we have common denominators. So I'm going to add together my like terms. So 13 plus 1 is 14k squared. Negative 9 plus 2 is negative 7k. And then my denominators stay the same. So different things to notice. The top, we have got a GCF of 7k. So I can take out that 7k, and I'm left with 2k minus 1. The bottom, a 6 is in the front, but there's no GCF. So we have got to do the x. So a times c would give me 6 over negative 5. So we'd have negative 3 and negative 2, because a negative times a negative is a positive. However, at this point, because there's a 6 in the front, this is the first one in a while we've had to do where you have to split the middle term. So the 6k squared stays the same, and we're splitting up the middle into these two terms. So we get a minus 3k and a minus 2k, and then that plus 1 stays the same. So I do my groups. So in the first group, I could take out a 3k. The second group, because it starts with a minus, I'm going to take out a minus 1. So I'm left with 3k. If I divide them both, I'm left with 2k minus 1. Then I take out the negative 1, and I'm left with 2k minus 1. The parentheses match. So 2k minus 1 is one factor, and then my GCFs are the other factor, so 3k minus 1. So that is going to go underneath my other fraction. So we've got 2k minus 1 and 3k minus 1. Thankfully, all that hard work paid off because these 2k minus 1s cancel. So our final answer is that 7k on top and a 3k minus 1 on the bottom. All right, hopefully that was helpful. So common denominators, you keep the denominators the same, you add or subtract the tops, and then you simplify using any of the skills that we've learned. All right, good luck with 8.3. I hope it goes well.